Thanks everyone for showing up. It's always a little nerve-wracking the last day, not knowing if we're gonna have anybody in the room. All right, if we could switch over, guys, to my session. Awesome. So a couple of things about this session. This is absolutely gonna be a fire hose. I have way more information on these slides than I can talk to. That is by design. The slides are going to be available at the online portal afterwards, or you can also email me or hit me up on Twitter. I'll give my email at the end of the session if you want copies of those. That way it lets me move through this without having to worry about reading everything on all the slides. A little bit of background, I've actually been hands-on in cloud for 12 years. I started super early, got hands-on in Amazon, kind of took a bet with my career. It's turned out absolutely horribly, as you can tell. By getting on cloud in the early days of that. So I've been in InfoSec for over 25 years. My side hobby is a disaster response paramedic. My wife calls it my very expensive hobby because that doesn't pay as well. And I've done a bunch of other stuff, and occasionally I like to dress up like a stormtrooper and go to children's hospitals and things like that. Now, what are we actually going to talk about today? So there's two pieces that I combined together for this session. And this is an area I've been doing a lot of work over the past few years about focusing on the incident response side and building threat detectors and response timelines and how do you actually build your security telemetry infrastructure. So that's the pieces I'm gonna cover, and we're gonna be taking from DevOps techniques to do that. So we're gonna learn how to leverage DevOps for incident response. This is not the session if you wanna learn how to instrument your CI/CD pipeline. This is the session if you want to learn how to do the move fast, break things that the DevOps world does and apply that to incident response to security operations. And I'm a cloud guy. I try to avoid as much on-premise as I can, even though I got acquired by a company, or my company got acquired by a company that does a bunch of on-premise stuff. So we're going to focus, for the most part, on cloud-native techniques here. But I will talk about how you can bridge that into your security operations center. Now, you've probably seen this. This is the normal DevOps lifecycle, and this is kind of form a bit of the basis of some of the things that we're going to talk about, where it's about that combination of development and operations. And one of the things that's really great about incident response and about SecOps is this is our world, if you think about it. Maybe it's not the cloud, the DevOps, CI/CD pipeline world, or it hasn't historically been that world. But detection engineering is basically all about performing your analysis and figuring out what you need to build and then handing that off to the next team so that that can actually be integrated into your security monitoring. And then when those things trigger, handing that information off to the analyst and then handling that information off to the response team. So there's always going to be, if you're in any scaled organization, a combination of different roles and responsibilities, which is why I think that DevOps is really a wonderful framework that we can use and take some of our notes from to improve our incident response processes. Because DevOps is more like a philosophy. There's not any one way of doing DevOps. But if we look fairly consistently at some of the characteristics, whichever definitions you look at, it's around collaboration, communication, automation, observability, and continuous improvement. And I think any of us, if you're at this conference, this is the world that we live in. And I think that all of these principles can apply. And if we map DevOps to incident response, this is kind of, my approach to this. Doesn't mean it's definitive, but if I look over on the operations side, or let's actually start on the development side. So a lot of that is around detection engineering, as well as our security engineering for building our pipelines and our information flows. And then that moves off into release, deploy, operate, monitor, incident analysis and threat hunting, response remediation, and our ongoing monitoring. And so this DevOps cycle does very much apply to what we do within incident response. And there's specific ways that we can actually map to those core principles of DevOps to IR, to SecOps, whatever you want to call it. I don't like to use the term SecOps. To me, security operations is a lot more than just the incident response process because it includes all of our day-to-day operational stuff. But for today, I'm going to use that at times. In terms of collaboration, so what are some of the things that we can do? You can think of this a bit as the summary slide. These are all the things that I'm going to talk about through the rest of this session. When you go into collaboration, we can talk about integrating outside teams into the IR process. The more you move into cloud, that becomes absolutely critical because you don't control any of their environments. We don't have the same degree of control as we do in on-premise data centers and on-premise offices. The more we move to remote work, the more we move to cloud, the more distributed our operations are. And as you'll see, bringing those teams back into the IR process instead of us trying to handle it in a bubble can really improve our efficiency and our effectiveness. That also means we have to have abilities to tune what we're doing to those different environments. I'll go over that. Now, in terms of communications, I'm a huge proponent of ChatOps. I think most of us use this in various forms of what we're doing, but I like using ChatOps as the tool to bridge between these organizations, and between these business units. I'll do a little bit of a demo of that, and we can actually use that as part of our IR process. And that's something I learned from somebody else who started doing that, and I'll tell that story when we get to it. We have automation, observability, and continuous improvement, all things that we can actually integrate into our process. Now again, remember, this is the more cloud-native approach. Some of these principles, many of these can also help you with your existing on-premise response processes and your data center processes, but I really am going to be focusing more on the cloud side. Now, apologies to our friends over at Google here. Most of my demos and stuff are going to be over on the AWS side because that's where I spend most of my time, but everything I'm going to show, everything works across all three of the major cloud providers. Probably also works on some of the smaller providers, but if you use one of those, you're screwing yourself so bad in so many other ways that it's not my problem anymore. So in terms of the cloud native characteristics that we can actually draw from and understand about, what is different about cloud that's going to affect incident response? I mean, obviously everything is ephemeral. I have a buddy at a large healthcare, and we were hanging out at DEF CON. We're both goons together, and he's like, hey, how do I search on an IP address and know who had it at a point in time? Because if it's an internal, if it's a 10.0.3.5, like if that shows up in a log entry in an ephemeral cloud environment, there may be 100 to 1,000 different things that have that given IP address at any given point in time, because you've replicated all these environments using infrastructure as code, and then something else may have it at one point in time versus when that incident occurred. These are the kinds of issues that we truly deal with if you've ever had to work in a cloud native environment or even support any kind of a cloud environment. We also have things that are much more event driven. That's actually an advantage for us from security purposes, and we'll go into that because security events give us some near real-time capabilities that dwarf anything that we're used to in our traditional infrastructure. Cloud attacks move fast, but cloud defenses can move just as fast. I'm going to be showing you alerts that pop over through a full detection system within 5 to 15 seconds of the attacker engaging in that particular attack. You can get that message routed to somebody who needs to deal with it. As I mentioned, everything is distributed, and we're also dealing with a lot of serverless stuff. We're dealing with things where there is no network. We can't rely on packet captures. So we have to start actually looking at different kinds of security telemetry sources in order to appropriately be able to monitor and respond in these different environments. And so what are the objectives of this particular talk? Well, we're going to focus on a couple of different major pieces of this. And as a bit of background, I've been teaching this stuff for years now. I actually run a cloud IR class with a guy named Will Bengtson who runs a bunch of this over at HashiCorp and previously Capital One and Netflix. We run a training class on this stuff. I've done a bunch of research on these areas. So these are the things that I have found that traditional incident responders maybe are a little bit less familiar with. And that's kind of what I decided to focus my 45 minutes on that we have here. So we're going to talk a bit about collecting cloud-native telemetry sources, how to build cloud-native threat detectors, using DevOps techniques to improve the detection engineering process, and then the integration of ChatOps. Because these are 4 really key things that I think can make a real difference in what we're doing. Now, in terms of collecting telemetry, it turns out the biggest problem that I encounter when I've gone out and done advisory work, and I've done a bunch of consulting with large orgs and everything else. I did skip one part of my background, so I'm currently SVP of Cloud Security at FireMon, but actually got in there through acquisition, built a cloud native product that they bought, and also worked as an industry analyst, started a company called Securosis, and before that was at Gartner. And through that, I've just worked with a lot of organizations over the 12 years who have dealt with these issues and helped them build their programs. And one of the most common problems that I've run into with IR is lack of access. And it blows my mind, and it makes sense to me. In a lot of our traditional ways of doing incident response and collecting security telemetry, we run off our tooling. We run off our Splunk, our Chronicle, our whatever you've got within your organization. That's where your logs, you collect it all, you do all of your analysis there and everything else. But that doesn't work the same way for cloud because we don't have access to that account, that subscription, that project, depending on which cloud provider you're working on. And that log entry, you have no context for what it means. And that's huge. We're going to go through something I call Schrödinger's misconfigurations in a little bit. But not having access to go look and see what is going on within that environment is crippling for a responder. Yet many organizations don't do that because cloud's moved really fast and nobody likes security poking their nose into their stuff. So they're not giving cloud teams access. And this has happened in some, I can't name who they are, massive organizations. So ensuring you have two levels of access becomes incredibly critical. One is making sure you have read access to do investigations because you're going to have to look at stuff. You can't rely completely on external logs and tooling to help you in your investigative process. And then having the ability to escalate to an admin level access to make changes. Because if that developer's not around at 3 a.m. on a Saturday when that attacker comes in and you have public data leaking, security has to have, and there's gate points and checks, we talk all about that stuff later, bug me about it, but we have to have a way for them to be able to get in and actually shut down to make sure that they can perform containment within that given environment. And so just some suggestion on how to do this: have a registry in place, make sure you have central ways of providing access, making sure you have some privilege escalation capabilities so you can go from read to full read-write. Now, once we have access to the environment, that's our kind of being able to go in and jump in. Of course, we want to be able to also collect telemetry. And the telemetry you're going to collect is going to be vastly different depending on the various cloud providers. So there's usually the core concepts of what these feeds are generally the same, and that's kind of where I'm going to focus things. But the actual implementation details are totally different across Amazon, Microsoft, and Google. So in cloud, we have to start thinking in terms of logs and events. And that's a really key point here in terms of our telemetry sources. Logs are things that are written down to files that we can collect in. And all the cloud providers produce these in different aspects. And if you go in, you may have between 20 and 40 easily different sources of telemetry within a given cloud provider. But there's a few key ones, and I'll go over what those are in a minute, that I always want to consistently collect across those providers. The thing about logs is logs tend to be slower because the process of collecting that data, batching it, and saving it adds a 5 to 15 minute delay into when you will be able to have access to that. And the way a lot of us set up our telemetry, and the way we do our analysis, that can lead to an hour delay in terms of what you see. And it's your choice, and I'm going to go through timing of these various things, but that might not always work out. Events are a bit different. Events are near real time. I like to think of events as it's the salmon in the stream. The event pops up, and then it goes away. It's not stored anywhere. It's not saved anywhere. There's no replay on these. However, if you have told your bear, grab every salmon that says STS get caller identity, which is the API call, then it's going to grab that and it can store it where you need it or forward it to where you need it. So logs are always saved somewhere. As long as you know where they are, you can yank them out. Events are these near real times, and you have to build rules and move the logs to either someplace to save, someplace to alert. And again, this is really consistent. Somebody correct me if I'm wrong. I don't do as much in GCP, but I've done a lot of this in both AWS and Azure. That's how you actually have to capture these events. And they all have mechanisms to do that. There's event hubs and event bridge, and depending on which platform that you're on, you're able to pull those events and move them to where you want to move them to. But you need to capture both. Because there's going to be different kinds of telemetry feeds, and some of them are going to go to logs and some of them are going to go to events. And even the log files might be saved in like a zillion different places. The core categorization of the feeds that we need, the most important one is going to be API activity. That's where I'm going to spend most of my time today. Those are those audit logs, management logs. It's CloudTrail in AWS. It's the activity log in Azure. And this is the actual API calls made by, not just by users, but internally within the systems, depending on the, shall I say, the maturity of the cloud provider. Those are really important. That's all the management level activity. Because remember, cloud, you're taking all these distributed environments and everything else. It's wonderful. Everything is segregated and isolated, except it all consolidates into a single portal for every possible administrative function down to rewiring the plugs on the switches. And then it puts it on the internet and it protects it with the username and password. So like, oopsie, that's kind of a problem for us. So you need to make sure you collect all that API activity. It's the single most critical feed for any cloud native kind of work. Then we have resource logs, and these are all over the map in terms of what they are. There's load balancer logs, there's storage logs, access logs. These are like wildly different on all of the platforms. This is a log from an individual resource. It could be a serverless function, it could be a load balancer, it could be an instance or a virtual machine, or a container. Sometimes we're going to use our traditional techniques to collect those. If I'm running a VM, I'm going to just collect those logs using a cloud-aware agent of some sort to, my EDR. I can pull that and I can store that. Or maybe I don't even collect that at all because it's in an autoscale group. Anyway, I don't have time to go through all the nuances of those, but those are resource logs. Sorry, and I got a little off. Resource logs tend to be more like serverless, gateways. Workload logs are the actual logs of the running workloads. We also have service and diagnostic logs, things that are logs that are from the cloud service itself, but that aren't like just the resource or just the workload. And then security tool and event logs. Now, these may not be logs. In many cases, they may also be events, depending on the provider, depending on your tooling that you're using. So, for example, let's go with Amazon, Guard Duty. Guard Duty creates events. Guard Duty can save logs, but only if you turn that on. Most people tend to work off the events and just feed it into their SIM as opposed to actually using saved log files. And it's important to understand the timing of all of the things that you're doing because there's what's known as the fast path and the slow path. There's an activity source. It's what created this entry. Is it an event? Is it a log? Which service is it? What is that? And this is kind of a framework that I came up with in doing a lot of this and using all of these services on multiple providers. You tend to have a fast path and a slow path, and the fast path to me is usually within seconds to minutes. Typically, you're going to get within less than 15 minutes. From that action occurring, you're able to collect that in a destination to perform some level of analysis. The slow path is going to take like 15 minutes to an hour. Now, true fast path to me is less than a minute. So I didn't throw that on here because I went over. There's usually a less than a minute scenario, a less than 15 minute scenario, and then a less than an hour scenario. Or if you're in Azure, it might be 24 hours until you see something. I tend to crap on Microsoft a lot because they're really bad at some things and really good at other things. But so this timing becomes really important because I've worked in organizations where they built everything along the slow path, and then they used regular old Splunk queries that ran every hour. So it could be 1 to 2 hours after something occurred before they see it. And if you've played with any of the attack automation tooling and everything on cloud, that's not going to work. By the time you see something an hour or two later, the attacker has just deeply run through your organization. I did work with a large government agency. This one was not in the US, so I've worked with the US ones as well. And in that case, they didn't even have anybody looking at events. They didn't have 24/7 coverage in their SOC. It was business hour coverage. It's like, okay, how can you possibly run an operation like that? And it was an interesting dichotomy because I was doing a lot of work with the people who were building all the detection engineering and response infrastructure. They really got this stuff. Like they were down to getting down. They knew fast path, they knew slow path, they knew which data went through which feeds. And there can be like nuances on these things as well. Like with AWS, fast path, you can get it all the write activity, but you can't get any read activity. So you'll lose recon. Azure, you can't get recon at all. They don't give you read activity in their API logs. This organization, they were really fast in terms of the security engineering piece. It was the response team that wasn't staffed up to do 24/7. And so that created a whole, I'm not going to even say it was a political mess. They all recognized it was a problem, but there was some deep changes that had to happen. Now, with all of this, understand that there's a lot massive volume of data you can be dealing with as you scale up within your cloud operations. And the way that we tend to usually think about things going in is collect everything in one place, and then that's where I want to run off of. I'm going to dump it all to the SIEM. It doesn't always work for cloud. If you think about the volume and the different kinds of logs and different kinds of security telemetry sources we're working with, that can break the bank, especially as you're in a multi-cloud environment, because this stuff is now distributed in all these different places. You have to deal with data transfer costs and storage costs. And so I've become a huge fan of a collection architecture filter and forward, where you can store logs locally, and then you push events forward. You push the security critical stuff forward using just writing rules to be able to push those things in different places. So instead of dumping everything to Splunk or to Sumo or whatever your tool is going to be that you're using, you're going to selectively dump important stuff to that maybe all the time. Like your management API activity, that's one that no problem. You can dump all that. Log volumes are low. Data transfer fees are going to be manageable. But then you get all the resource logs, all your workload logs, all these ephemeral logs. Sometimes it's okay to keep those in a different system, and then you send the alerts central. And I'll show a little bit more of that architecture in a bit. But that's definitely one way to get some more efficiency out of it. And there's just some examples of the different provider feeds. I'm not going to go through these. Again, as I said in the beginning, some of these slides are here just as references for you later. You can email me, take a picture of the screen, get them offline, because it takes forever if I actually talk through all of these. But they tend to be very compatible in terms of the feature functions, like going back in. You always have API, you have service logs, workload logs. The names, the granularity, what you get, the nuances are what's going to kill you. I love that I can do recon in AWS. Although I can't do recon on my fast path, it's my slow path. Although that may be changing, is a rumor that I heard. But I can't do any recon detection in Azure because Azure doesn't let me see read activity. It only lets me see change activity. So it's a little bit of handcuffs that I have to operate on. Then all of the providers also are pushing all of their own tooling all the time. Okay? And I'm going to be, we're here at the Mandiant conference. We've got Chronicle out of Google. Azure's got Sentinel. AWS doesn't have a SIEM at all. And then there's CSPM tooling, Cloud Security Posture Management for your configuration management pieces. All the providers have that. Vastly different maturity levels. For example, over on Google Security Command, within Google, you can actually get some historical information about resources at point in time. You can't get that in Azure, and in AWS you can get it, but only if you turn on config, which gets to be kind of expensive. So even though they all have these different kinds of tools in different ways, the short answer to this is if you do this work for real, you or somebody else needs to be a subject matter expert on every platform you use. And I can tell you from my personal experience, 12 years of doing this crap, and I'm pretty good on AWS. I can kind of hold on by my fingernails on Azure, and I'm lost on Google because nobody can know all of these. Nobody can know all these. I go to all the cloud conferences. I hang out with all the best cloud people in the world. Nobody is this good on all three platforms. So if you're a big enough team, you need a subject matter expert for each platform. There's just no other way to go ahead and survive on this. And if you're smaller, then you're probably going to have to rely more on vendors and stuff and outside consultants, but at least have a primary cloud where you have somebody who's really good on that primary cloud. I can't express enough how fundamentally different these platforms all are at the deepest technical levels. They look the same on the surface. They do not operate at all the same way. So here's an example of how we categorize these things. And one of the ways that I like to think about it is I have my more operational set of stuff. And that tends to be my logs, my CloudTrail, my resource logs, my events, my config. These are the operational things that, like, if I'm an ops person, a developer, an admin, I need to look at that stuff as well. But then I also have a set of feeds that are security specific. And again, every cloud provider has these. These just happen to be the Amazon ones because these are the ones that I personally use more. And so on the security feeds, there's threat and feed sources as well as response and tooling capabilities. So like threats and feeds, again, in the Google world, Security Command Center consolidates most of that information. And then the response and tooling, we've got like Chronicle and a whole bunch of the stuff that's being built over there. So you need both the operational and the security, because the providers are going to frequently see a lot of things that you are not going to be able to see yourself, or you can't see yourself in a cost-efficient way. You could build detections to fully duplicate guard duty in AWS for the most part, but you'd have to turn on a lot of stuff and pay for it that you kind of get built into the guard duty cost if you just turn guard duty on. And so the pattern for all of this, with everything I threw at you, how do we actually look at collecting all of these different pieces and everything else? This cascade and filter program, I have my individual accounts or subscriptions or projects in my cloud environment. There's going to be a bunch of things I'm going to collect locally to those that may not be centralized. Raw logs I'm going to tend to send to a SIEM or something else, particularly my activity log, my API activity. The other stuff, I may do some local analysis and just send the alerts out to my cloud detection response tooling, whatever that is. Now, my CDR, which is a newish category, I can send alerts from that to my SIEM, or I can have my SIEM send alerts to the CDR, and the CDR becomes the handling tool. I don't care what you do. And then there's a couple of other feeds that are going to come into play here. The predominant one is your configuration management, your cloud security posture management stuff. A bunch of tools out there. So again, with Amazon, it's Security Hub. With Azure, it's Defender for Cloud. With Google, Security Command Center, and then third-party tools, like mWISE and Prisma and Orca and MyShit. Oops, sorry, bad language. And all those, whatever those tools are. And we're going to get a little more into that in a moment as I go into detection engineering, why I now include configuration changes as part of my detection process. And then remember, you can alert everything centrally, but then you still have the ability with your read access to jump in and do the investigation locally. In a bit, I'll show you what some of that looks like. Any questions on the speeds and feeds stuff before I start blasting through detection engineering? All right, so it's a mouthful to get through all of that. Now, in terms of the detection engineering process, what are some of the changes that we have to deal with? Well, I've got a management plane in the API activity, and it's different kinds of detections than I had to do before. And those IoCs and everything that we're used to are completely different. Those just this is a whole different world of how you have to build these things. We now start focusing on building alerts based on API call usage. Not necessarily, there's no network activity or anything associated here, or endpoint activity. So it's a new set of domain knowledge to deal with your engineering of your detectors on this. We also have the issue that our deployment environments are going to vary widely. So I'm going to get the same log feed from a development or a production environment, but in a development environment, I'm going to have activities that in production would be absolute definitive indicators of compromise, that in development, it's just kind of what the devs do to get their job done. And so we have to be able to treat these environments differently, because I can't treat my production environments, my detectors, the same for production and for development environments because of how they operate. And remember, because all of these things are potentially internet-facing or likely internet-facing. We also have the cloud security provider or cloud service provider feeds, like guard duty alerts, like command center alerts, Defender for Cloud alerts. Those aren't always accurate. Or maybe it's accurate, but it's not accurate in this situation. An example is some of those use heuristics, and the behaviors will trigger in a development environment for innocuous activity that, again, in a production environment would be a solid indicator of compromise. And so we have to understand the nature of those feeds. And things like IP addresses change and configurations come into play. So what can we do that's kind of like this DevSecOps world around our detection engineering? There's a couple of baseline things, which is we should leverage DevOps stuff to actually build and manage our detections. So write things in standard text templates, keep them in version control repositories. Tag them so that they apply differently for different environments. It's blue-green testing, basically. Blue-green detectors. Apply this one in dev, don't apply this one, apply this one in prod. We need to have the detectors work for all these different speeds and feeds. There are times where you're going to still be using your old school SIEM, and then maybe it's cloud native and everything now, but what I mean by that is there's certain kinds of detections like, hey, I've looked at all this time series activity of this is a read event, a read event, a read event, a read event, a change event, and that pattern, specific pattern, could be indicative of recon 2 compromise, where a lot of the more real-time tooling, like this is just a known bad API call. This is just a known bad IP address originating this API call. That's going to be a single detection, and I can run that in a different part of my infrastructure. And I'm not saying this to confuse you. As you get into this, as you get the training, as you work with the tools, you will understand over time where to build these where it's more effective. It's not like these are, impossible, like magic AI science problems. This is very deterministic. It's just a matter of knowing what those are, getting that subject matter expertise. And then we're going to be dealing with filtering. And one of the interesting things is that I'm a real fan of like test-driven development, behavior-driven development techniques. Organizations that are really good at all this stuff I'm talking about today, they tend to hire people with development skills to work on the security team. And in some of these, like some of the Bay Area companies, they only hire people if they have at least some level of coding and scripting. And they're following a lot of these development kinds of techniques and these cycles for building these detectors and detections. It's not just simply writing queries in one tool. All right, we're not just Splunk console jockeys anymore in this world. You actually have to have that behind the scenes understanding and engineering around these pieces. And one of the things that can be really great is we can actually build all of this into a cycle. So this is the detection engineering version of the mapping to the DevOps Infinity, I don't know, whatever they call this. I don't even know what the name is, where we have a definition phase at the start. So that's in that kind of upper left corner there where we go with the coding. So a definition might be, I want to identify there's an example I'm going to do later if I have time, a demo of a real-time detection. So if somebody takes a snapshot of an instance and makes that public, that's probably a relatively definitive sign of either a compromise or somebody doing something they shouldn't be doing. Because in an enterprise organization, you don't make snapshots public because then anybody can gain access to the data. So step one would be, my definition is, I do not want public snapshots. Then there's a bunch of different ways that I can detect that. I can detect that through my posture management tooling that detects public snapshots, but I want to get that in near real time. So then I'm going to send that over for coding and engineering. How can I detect that in near real time by looking at that API activity? Once I've written that, then I have to test it. And so you have to have a test harness framework that you can actually simulate those attacks. Not everybody does this, but I'm a big fan of this. We do use this. Some of you, if you use this for your existing detectors as it is, but we're now looking at more activity, not like an IOC. We don't have to spoof IP addresses or anything. We just have to go ahead and simulate that series of events. So you should have that automated to test that, and then you can test it in different places and in different environments to make sure detections work in the way that it should. There's a tuning process that we go through as we release it, and then when that alert occurs, we want to enrich that data. I want to know what environment did that come from. I want to know what the ID is. I want to know who did it. All that enrichment should be done automatically by my systems. I shouldn't just get a raw API call where I have to figure everything out myself. And then over time, metrics and feedback for tuning it. So this is all following these continuous lifecycle approaches to doing my detection engineering. Now there's different places to detect these. And as we talked about, we had logs and events, but now I'm adding in this configuration piece as well. So logs is going to be pulling the files out. I treat those really similarly to everything you've done before in terms of pulling those out, putting them into a SIM. That's most likely the place where you're going to do that. And then you can do your log analysis. And that's where you're going to find your low and slow. That's where you're going to find interesting things maybe you've never seen before. The other side is the events and the alerts, particularly the ones from the security tooling. And your main focus on those starts to become, is this a good one or a bad one? Which environment is it in? How much do I trust this particular event? What other analysis do I need on this event? And that's my near real time. I'm going to be able to gather that information within seconds. Now the configuration one gets to be interesting. And it's something that I call Schrödinger's misconfigurations. So everybody's heard, Schrödinger's cat. If you take a cat, you stick it in a box with a radioisotope, and if that decays, it triggers something that drops a poison that kills the cat. And you close the box up. It was a thought experiment. You don't know if that cat is alive or dead until you open the box. And the act of opening the box, the observation makes the event. And it's all quantum mechanics garbage. And I just slaughtered and destroyed the proper definition of Schrödinger, but of Schrödinger's cat. But the fundamental concept is the observation makes the event. Like, you don't know what it is until you look. And that has a lot to do with quantum mechanics. Where looking at something collapses it to a known state. Well, this is what misconfigurations are in cloud. Because if I have a public snapshot, that snapshot exists in 3 given states once I know that that's there, or that occurred. 1, that's an attacker exfiltrating data, or a snapshot shared with an account that I don't recognize. 2, that is an accidental misconfiguration by somebody that works for us. Or 3, so it's a policy violation, but it was a mistake. Or 3, it was a deliberate misconfiguration, either for malicious reasons or because they were just lazy and they knew what they were doing and they just did it that way. And until I investigate, I don't know which one of those it is, those misconfigurations. Public S3 buckets, it's another great example. Not all public S3 buckets are bad. My platform, so it's called DisruptOps. Our entire cloud SaaS platform is hosted in an S3 bucket. It's a single page app hosted in an S3 bucket. We don't have any web servers. It's great. It's serverless. It gives us all this security and performance advantages and everything else. But it's a public S3 bucket, so that's a known good state. If one of my developers, if another S3 bucket shows up in that account, that might be bad, because that might be customer data leaking. I don't know. We actually don't collect a lot of it, but so you don't know until you look. So these misconfigurations, how do you actually tell? How do I get my index of suspicions around what misconfigurations I should focus more on or less? Is this good or bad? Well, one would be maybe source IP address. We have a live fire training range we use in the training class, and I'll do some where I run the attacks from my laptop. That's kind of how I'm going to do today if I have enough time for the demo. But we have others that I'll route it through VPNs in Hong Kong and other parts of the world, just so this to change the index of suspicion as the students are looking at that information. There's also if I have recon activity followed by an action. So if I have STS get caller identity, what are my credentials? Who am I, kind of a thing. Well, that's a sign of an exposed credential and somebody trying to figure out who that credential is, what account it's associated with, and what it could potentially do. So I can look for recon activity, and then something occurs. Because if it's a standard service account or something, you're not going to see recon activity. It's just going to do the same thing all the time. This is where logs are really helpful, because you can actually go through and start looking at your patterns and your analysis. The environment, obviously dev, prod, and what goes on in those. In our case, our production environment, we have 2 or 3 production environments right now, and all of those are managed through infrastructure as code. People don't log in to make changes. We'll do a little bit of tuning sometimes of capacity and things like that. I go in manually to configure some of the security, but none of my devs ever go in. All that's through infrastructure as code. So if I see a user level pattern change in that environment, it's definitely going to increase my index of suspicion. And the last one is just to ask. So this is the whole chat ops thing. There's this guy, he used to be over at Slack, Ryan Huber. He's off into startup land for the past few years. Ryan, I met him at Black Hat. A mutual friend introduced us. And he's yeah, when he was at Slack running a bunch of the security at Slack, he did a thing where if he got alerts in the SIM for certain things, it would just send a Slack message to the user that originated that activity. And in Slack, they could click a button that said, I meant to do that. And then it was de-escalated. If they meant to do that and it's within the boundaries of what they're allowed to do, cool. I don't need to necessarily investigate. Now, it's a simplistic example in these days, but totally worked. He said it dropped the stuff that he had to spend his time on by 90%, just by asking, did you mean to do that? Now, where do we detect these things? Tons of different places. For time series stuff, you're going to be in a SIM. For real-time events, that's where that cloud detection and response kind of tooling comes in. CSPM, this is a little bit redundant for some of the other stuff that I talked about. I do get asked a lot about what are detectors. This is an example of reference slide. These are the CIS benchmarks. And sometimes we knock on CIS because these don't all apply equally in all environments. But this is not a bad starting list. This is the AWS version, and they also have Azure and GCP versions. So if you don't know where to start, your vendor tooling can help you, CIS benchmarks can help you, and then as you're getting up to speed and learning these things yourself. These are just some examples. These are AWS-specific examples of ones that I like to use. Oh, sorry, that's on the next slide. Or did I skip a slide? There we go. These are some examples. So like API calls coming outside. So some orgs, they don't allow anybody to manage their AWS environment or their Azure or GCP environment outside of their known IP addresses, financials. And very few have been able to do this. It's actually very hard to do. But put a list of known approved IP addresses. Again, you can at least do a detective control on it and know, did it come within my range or did it come from outside of my range of known addresses? Obviously, work from home and zero trust and everything are complicating this, but there are ways to still manage all of that. Or things shared outside of my account, or STS, get access key info. These are just all examples of some of the kinds of detectors that you can actually, or basis that you can actually use in some of your detectors. Now remember, a lot of your normal IoCs will still apply, particularly if you have virtual networking. I don't recommend capturing all virtual network traffic in cloud. I have a whole days of lectures about cloud network architecture stuff. But there's a lot of different, but a lot of IoCs and IP address things will still apply. And focus more on the management plane, I think, is going to be the biggest change if you haven't done this work before. Spend more time on the management plane. I call it cloud log before syslog. Like your endpoint logs, they're still useful. Your network logs, they're still useful. But the things that are really going to kill you in cloud, the really bad ones that get you in the newspapers, are within the management plane. You all already know how to deal with more, existing traditional attacks. You don't need me to teach you, or you could teach me those. You're better at that than I am. But for the cloud stuff, you have to focus more on the management plane activity and the cloud native sources. And some other things to kind of focus on, just some general tips, IAM changes, things that have become public that have not been public before, things shared across different environments, unexpected network changes outside of your infrastructure as code, pushes, anything that happens outside of pipelines. These are all like cloudish, cloud native kinds of things that you can use to actually help you in terms of detecting stuff and building your detectors in this more cloud native way. Also, canaries, really, really valuable in cloud. The biggest source of all cloud exposure is exposed credentials. The biggest source. Ask any cloud expert, look at any statistic. It's not somebody hacking into a server, it's exposed cloud credentials. Merely, sometimes I get that by hacking into servers. So putting canaries into place can also be a really valuable way to actually narrow down where you have leaks within different teams or different portions of your environment. And then lastly, you want to test and simulate. So there's two levels of this. Remember, we're now in this really crazy distributed environment where we have all these different accounts and subscriptions and topics and cloud providers. You want to make sure that your detections are working across all of that. And so you can do fault injection to make sure that that's still up and running. Like in our demo classes, I'll just show you a little preview of it. Like this is my dashboard. I have 200 accounts wired into this, and that I can run a series of attacks across all of them to make sure that my detection stuff is still working. And like if I go into this one here, which is an account that I got running right now, and just go ahead and launch that attack. I actually got to run my Docker image because I think that shut down when I closed my laptop. And we'll give that a moment, but to go ahead and run because that Docker image has got to pop up. But this is making sure that, and it's going to send the alerts through chat ops like this guard duty notification. But oh yeah, and I just got it. So now I know that that works. That environment is properly instrumented. What happened is I just got an alert that I used a static access key in that environment because I set that as one of my alerts. And then as the attack finishes, because the attack actually takes a moment to run, going in here, it's doing a public snapshot. I should actually pretty quickly get that alert coming through as well. So it's testing the different levels, and doing that on a continuous basis is something pretty powerful that you can actually build into your program. So there's been some, I think there's at least one open source tool I know that's about to be launched around that. Then, to finish up, distributed response. And I talked about using that chat ops. We use this internally. Anytime somebody accesses production, that generates an alert that goes to a shared channel for that dev team, and they have to indicate there that they meant to log into production. And if they don't do that, then we have to kick in a response process associated with that. If you get misconfigurations, send those to the team. Let's see if the one I just ran came across yet or not. Yeah, it did. So like this snapshot is public. Investigate it or do a delete action right here. This gets routed. This is a training demo environment. This gets routed to whoever's responsible for that environment, and a version of it also goes to security. Because the entire nature of integrating those teams, they know if that snapshot should be public or not in their environment. Security should also always know what's going on. And so using these tools like ChatOps to get these alerts, do some analysis on it, enrich it, and then send it to the team responsible for it, and then send another copy of it to security, and then track the approvals. So yep, we meant to do this. So I've tracked that. Now I have that gone ahead and recorded in my system. They're now accountable for the fact that they made that change, and then they out-of-band approved that change. So this gets that local knowledge into place, the people that know what they're doing on that team, that know their environments, are engaged in that process of IR instead of me trying to figure it all out from analysis workbench. Because I can't do that, and I'm pretty much out of time, so I'll blast through this. Because if I look at and go through the actual threat hunting process, this is where all this subject matter expertise comes into place. Like, you have to know what's going on in the cloud provider, and you have to know what's going on in that individual environment. And sometimes the providers don't make it easy for you. Like, identifying AWS resources, there's 3 places this can show up in a CloudTrail log. And like the one called resources is the one where you're least likely to see the resource name associated with the actual resource itself when you're going ahead and looking at it. And every one of the cloud providers has their own way, their own issues in terms of doing all this. So what can help us, can help our responders is, do automated enrichment, throw a bunch of that configuration data in there. Have these automated runbooks and playbooks. And the demo I'm going to skip was me running query examples because I have pre-built queries. I can just pull those out and I just go click, click, boom, and I can actually do a deeper investigation on kind of common issues around that. Doing analysis as code, having that pre-built, writing things more in Python. I know there was a demonstration of that yesterday. I wasn't able to go to the session, but I saw it on the agenda. And then integrating with your cloud security posture management for the configuration, as well as your inventory of your cloud inventory to support that investigation. You guys can't do proper investigations and threat hunting if you're just looking at logs. You have to be able to go into those cloud environments. And so the last slide here, when I look at this DevOps approach, when I look at all the stuff I threw at you here, what makes me more mature? How can I actually improve myself on this timeline? Well, a lot of us, we always start with this ad hoc, kind of doing everything by hand, probably what my demos look like. Eventually we'll get to documented. We start getting some runbooks, playbooks, and policies in place. Then we tend to see organizations managing this through like a ticketing system. But eventually we get into the automation and then policy-based automation phases of these. And that's really where we're storing this stuff in version control repositories, and we have automation pipeline and an automated detection engineering process. This is doable. I've seen this done. It is a small percentage of organizations today because cloud's still relatively new. We're not bad at what we do. We just need time to catch up with things that are going on around us. And so continuous, collaborative, automated, define, and distribute it. Thank you for your time. I apologize for running over there. And if you need to get a hold of me, I'll go hang out in the back of the room for any questions so we can let the next people get up.